on a computer, you're changing, increasing or decreasing age, something is happening in terms of time. Right, the computation time, if you do 100 time steps or 1,000 times step, the calculation is 10 times larger. So if you can do this calculation in 1 minute, this calculation you are going to do in 10 minutes, correct? And of course, in real biological or biomedical problems, you are sometimes solving, say, 1,000 equations at a time, not simple dn dt equals n. And in that case, such considerations are very important. Like, how do you also optimize the time of the computation? So if you consider all three things, those two errors, and three very important computation time, all three together gives you an idea of how to do H, okay? How to decide H. Now, this also brings to the topic of stiff equations. Anybody knows about this? No? Stiff equations? So, suppose you have two time step in the equation. So if you have this equation, d2x dt2 plus 101 dx dt plus x equals 0, then xt is negative minus 100t plus 100 e to the power minus t. So now you see you have two different time constant. One time constant here is e to the power 100t, and the second time constant t2 e to the power minus t. Okay, so you see, do you any question there?
Yeah.
Yes.
On the board, is that 101 dxdt or is that
101?
Okay.
101. Yes. Now, you see this time constant is 100 times faster than the T2. So you see a fast decay like this, and then it decays very slowly due to the power minus t. So you have two modes in the system. One mode, rapid decay with e to the power negative 100t, and then the second mode is very slow decay with e to the power minus t. Okay? Now the question is, how do you choose the time step in such a scenario? The problem is, initially your solution is decaying fast. So you need to choose very small time step to make it accurate. Does this make sense? Whereas once you decay by this, you end up with a slow decay, then choosing a very small time step just wastes time. Okay? You need to switch to a faster time step or like bigger. So then you can solve or bigger intervals. Whereas here, you need to solve over tiny intervals. Does this make sense? So you need to kind of switch from one age to another. And in MATLAB, you'll see several routines ODE 15, 23, 45, and also you'll see 15S, 23S. So the next lecture I'm mostly going to devote to MATLAB, and I'm going to show you a few simple examples. So one thing you can try if you get a chance before Wednesday's lecture, remember the receptor plus ligand binding equation I wrote? Try to solve those three equations in MATLAB using ODE either like 45, that's probably best. Try to solve that using ODE 45. Go to MATLAB, go to help, and type ODE 45 example. So look into ODE 45. There are examples, and try to see if you can solve this three set of coupled equations using ODE 45. And I'm going to discuss it in the lecture, but it will be nice if you have some preparation. And 15S and 23S, S means stiff. So these two routines in MATLAB are designed to handle such situations where you have two very different time constants, very fast decay and a slow decay. Okay? So if you are given, I think homework problem, anyone has homework problem with you? Take a quick look into it. So I think homework problem 3 you need to solve using Euler scheme. So you need to choose, I think it's either given or you need to choose H. It's given? Okay, so that's then easier. So you choose H01, then you write Euler scheme using this. Now if you have a second order equation or a set of coupled equation, so the trick to do that is suppose you have d2x dt2 equals omega 0 square x. The equation which I solved analytically, the cosine and sine solution. So how do you solve such thing numerically? Of course, this has analytical solution, but in the general case, it may not have such analytical solution. So the way to do that is you choose dx dt as a new variable or dx x1. Okay, and then you do dx dt as another variable x2. Okay, so you make a change of variable. So d2 x dt2 becomes dx dt negative omega 0 square x, so which is d dx to dt equals minus omega 0 square x1. Do you follow? Are you with me? So I am redefining my variables. I call x as x1 and dx dt as x2. Okay? So this is same as writing dx1 dt as x2. So I have now two equations. I have dx dt or dx1 dt as x2 and dx2 dt as negative omega 0 square x1. Anything you did not follow here? So what happened, I started with a second order differential equation and I changed them into a set of two first order equations. Okay? So which I can write in the matrix form d dt x1 x2 equals 0 1 minus omega 0 square 0 x1 x2. Are you with me? Now call x1 x2 as a vector. So I get dtt x as a times x. Are you with me here? It's clear? Anyone did not understand? Okay. So can you tell me how to proceed from here using Euler scheme? So you need to write the Euler scheme x t plus h as xt plus dx dt h at t. Okay. It's the same formula, same Euler scheme. Only difference is now you need to do it in the matrix form. That's the only difference. Everything else is same. Correct? So you write, you start from 0, so you do x 0 plus h That's it. So instead of doing simple addition, you need to do vector, like you need to keep track of two components, x1, x2 plus this, like this. That's all it is. But the same idea. Okay. Can I take a quick look into? Thanks. So in problem 3a, if you look, that's the second order differential equation. And that you need to change this to a set of two first order equations, okay, and solve using the Euler scheme. So why don't you